let's finish up with a few quick modeling problems. So here we have a diagram here. Take a moment to read the scenario. Pause if you need to. Now the diagram that's provided helps us to determine what it is that we need to solve. So it says we need to figure out how much distance is saved. But I first need to know what this total distance is here that a student would walk. And in order to figure that out, I need to solve for x. So because we have a right triangle shown here, it means we can use our Pythagorean theorem. Our legs are going to be a and b, so we have x squared plus x plus 20 squared equals 50 squared. Now what we do before we solve for x is we need to expand this and get it into standard form. So using our rule for a binomial squared, we know this is going to multiply to be x squared plus 40x plus 400 equals 2,500. So we're going to combine like terms. We have 2x squared plus 40x minus 2,100 equals 0. So what we want to do is look to see solving or factoring this. Well, first thing that we can look to see is that, well, we're going to have a leading coefficient, and we actually have a common factor between all of these. So let's take a look and factor that out and then determine using a discriminant whether or not I can factor it or if I have to use the quadratic formula. So I factor out the 2 and I'm left with x squared plus 20x minus 1,050. Now let's go ahead and use our discriminant to see, do I need to use quadratic formula or can I factor? So the value of a is 1. The value of b is 20, and the value of c is negative 1,050. So b squared minus 4ac, we're going to have 400, or let's just fill it in first. So we have 20 squared minus 4 times 1 times negative 1,050. So we're going to have 400 plus 4,200, giving us a total of 4,600. Now, because 4,600 is not a perfect square, that means we're going to have to finish by using the quadratic formula. Now, the bright side is that we are halfway done with it because we've already determined the value of the discriminant, so we know the value of the radicand. So we just need to finish filling out the rest of our quadratic formula. So if our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and we fill in what we already have, so we know the value of b is 20 plus or minus the square root of 4,600 all over 2 times 1. So then we can just finish solving at this point. Now, what's important to note is we do not need to simplify the radical in this case because it says to approximate how many feet are saved. And so what we're going to do is we are going to go ahead and just round to the nearest whole foot. We're going to round to the nearest whole foot. So we're going to get the nearest whole number. So what we can do is we can take negative 20 and we're going to add and subtract the square root of 4,600, which is approximately, when rounded up to the nearest whole number, is 68. Oh, and then divide that by 2. So we're going to solve both of these. We have negative 20 plus 68 divided by 2, and we have negative 20 minus 68 divided by 2. That gives me values of x that are 24 feet and negative 44 feet. Well, since distance can't be negative, we can actually ignore this negative value. So we have the values of x here as 24 feet. So we've got 24 feet here. We have 24 plus 20 feet, which gives us 44 feet. And so the total distance walked by going across the sidewalk is going to be the 24 feet plus the 44 feet, which is 68 feet. And by cutting across, it's only going to be 50 feet. So if we subtract the 50 feet, we are saving 18 feet approximately by cutting across the grass rather than walking the length of the path. Here in our last example, we have a classic projectile motion equation. We have an object thrown upwards from the top of a 200-foot cliff with a velocity of 12 feet per second. Now, a lot of students see these numbers and go immediately thinking that they need to be put into the equation, and that's not always the case. So let's analyze the equation at the same time. The height in feet of the object after t seconds is given by this function. How long after the object is thrown will it strike the ground? Round to the nearest tenth of a second. This is also another hint right here that we're not going to need to simplify our radicand. We can go ahead and approximate the square root because we're going to be doing some rounding. Now let's consider the numbers that we're given. A 200-foot cliff. That is already given in our equation as the starting height. With a velocity of 12 feet per second. That is also already given in our equation. So what we need to do is we do need to figure out some value for height, because our question says how long after the object is thrown, which means we're solving for time, which is our variable t. So they have to tell us something about the height. So how long after the object is thrown will it strike the ground? The ground tells us that the height is 0. So we can go ahead and substitute 0 into the equation. And then we can use our quadratic formula to solve. Something that makes it a little bit easier, like we did earlier, is if you have a GCF, you can factor it out first to get smaller numbers and then plug those into the quadratic formula because it's going to give you the same solutions. So here, I notice that I have a common factor of 4 or -4. So I'm going to go ahead and factor out -4 just to make the equation a little bit simpler. So we have -4. I'm left with 4t squared minus 3t minus 50. So now I have some smaller numbers to deal with that I can plug into my quadratic formula. I can use 4 as the value of a, -3 as the value of b, and -50 as the value of c. Our quadratic formula, x equals -b plus or minus square root of b squared minus 4ac all over 2a. So we substitute our values in. We have -3 plus or minus -3 squared minus 4 times 4 times -50 all over 2 times 4. So when we clean that up, we are left with 3 plus or minus the square root of 809 over 8. Because we're rounding to the nearest tenth of a second, that means we can go ahead and estimate the radical. I want to keep a couple extra digits, or you can plug in the entire equation at once. We are solving two different problems now, 3 plus the square root of 809 over 8, or the square root of, or 3 minus the square root of 809 over 8. When we evaluate both of these, we get approximately 3.93, which rounds to 3.9. And we get approximately -3.18, which rounds to -3.2. Because time can't be negative, we can disregard that, which means that it takes approximately 3.9 seconds for the object to hit the ground.